Hey guys, and welcome to another C++ programming tutorial from Someone9031. And today the tutorial will sort of be an add-on to my original dynamic memory allocation tutorial. And the reason is because in my original tutorial I discussed the concepts of dynamic memory allocation. I discussed the heap or free store, and I also talked about bad pointers, stray pointers, stuff like that. But in that tutorial, I have realized that I forgot something very important, which is why and when you would use dynamic memory allocation. So that is what this tutorial is going to be about. Why and when you would use dynamic memory allocation. So let's get started. Basically, the first and biggest reason that you would use dynamic memory allocation is so that an object or a variable that you create will last after a function is ended. So let's take this example for instance. I'm going to write a very simple function here, and let's see, int. It will return an int pointer, and it'll be called add 10, and then it'll take int a. Now in this function I'm going to have a plus equals 10, so add 10 to a and then return the address of a, because what we specified here is that we are going to be returning a pointer, and yes, to return that we return the memory address of the variable. Now let's try this function out. So cout, actually let's create int p equals add 10, 12, and then cout p. So if you run this program right now, just let it process and build. And as you can see from my output, I get a warning here, but we'll look at that later. It's sort of important, but we'll look at that later once we see the output from the actual program. And the number we get is 15214208864, which clearly is not 12 more, is not 10 more than 12. So clearly we've done something wrong here. Now let's go back to that output that we got from our build. It says here, warning C4172, returning address of local, variable, or temporary. And I'm sure probably a lot of you can see what is wrong here. And if you can't, let me tell you. Basically, what is wrong here is a is an argument passed to a function. It is passed by value. And so a is the value that is passed in. A is a local variable, which means that it is local to this add 10 function, which means, like all local variables, it is deleted, its memory is deallocated as soon as the function ends. And the system is free to put anything else it wants there. And obviously, in this case, it has. So, yeah, this is where dynamic memory allocation comes in. What we can do here is int pointer p equals new int 0, and then we could do p equals a plus 10, and then this time, instead of returning the address of a, we return p, because p is already a pointer. If we run this again, here we get 22, which is what we want. Now, when you do something like this, you have to remember to put back this memory that you allocated here at P, that you allocated to P in this line right here. And you might be asking, well, how do I do that? We need P to be passed back, so we can't do it within this add 10 function. And then once it exits, what way do we have of deleting that memory? Well, the simple answer is, because we set this pointer P to add 10, 12, which returns a pointer, which is actually an address, so P now contains the same address as this P here. So if you call delete on the P that we have in main, then it will be deallocating the same memory address as this P up here. So that is how we get rid of it. We just go delete P, like so, because it points to the same area of memory. Now, when you don't dynamically allocate and you return the address of a local variable, it's something known as returning a bad pointer, which means the pointer doesn't point to anything, doesn't point to the value that you want anymore, so it's a bad pointer. Now, the second reason why you might use dynamic memory allocation is because when you have dynamic memory allocation, you allocate memory to a pointer, so you don't need that pointer to point to an actual variable that you've created. It points to an area of memory in your heap. So we don't need to create an extra int object to have P point to. P actually just points to an area that you allocated in memory. And the reason why you would use this is because it allows you to have the functionality of a pointer, which is very important for pass by reference, and also for object polymorphism, which we'll get into after we look at class inheritance, which should be in the next tutorial, I'm hoping. Anyway, so yeah, it allows you to have the power of a pointer, but not have to create an additional object that it refers to. So we didn't have to go int obj and then int pointer P equals the address of obj, like we used to when we first looked at pointers. That's not really necessary, because we just want the pointer to be able to store a value. It doesn't really need to refer to an object. And another reason why I use pointers is because polymorphism relies upon pointers and virtual functions. So without a pointer that you use for an object, then you can't use polymorphism, because you can't do it on just a plain object. Yeah, so basically the second reason is it allows you to have the power of a pointer without the hassle of having to have an object that it refers to. It's just an object that's created in the heap. So yeah, that concludes the tutorial. If you like this video, please subscribe, rate, and if you have any questions, comments, or feedback, please feel free to leave them below in the comment section, and thanks for watching.